So, as discussed earlier, we can use where clause to filter the records. Here, we are using some comparison operators like equal to. So, to use equal to, we have added where clause with condition product ID equal to 20. If we run this query, select star from table where product ID equal to 20, okay, where we are getting all the columns having all the rows which are having product ID 20. There are around 84 rows where we are getting product ID 20. Okay. Similarly, we can use greater than and less than. Here I am using greater than equal to 20. So we just wanted to find out the records where product ID is greater than 20. So if we run this one, we will get all the records where product ID is greater than 20. So that is 26, 22, 23. Okay. It will not print 20 because it is greater than. Okay. And there are around 2900 something records are there. We can have product ID greater than or equal to as well as or less than or equal to, but in this SQL query we are just using less than or equal to. So if we wanted to find out the product ID less than or equal to 20, then we will get result like this one where equal to is mentioned, so 20 is also included in our SQL criteria. That's the reason 20 is printed over here. Okay, and all other product IDs are less than 20. Okay, so there are around 1763 rows. Then where clause with not equal to, so we can use this syntax for not equal to. It also support this one, but I used to prefer this syntax. And if we run this one, we will get all the product IDs. Doesn't matter whether it is less than 20 or greater than 20, but it will not give the product ID rows having value 20. Okay, then let's move to logical operators. The first logical operator is AND. So we are adding the condition like product ID equal to 20 and item ID equal to 2. Okay, so if we run this one, so AND means we have to ensure both the conditions should be true. Okay, and that's the reason we are getting item ID as a 2 and product ID as a 20 in all the rows. There are around 23 rows. Okay, now or applying same condition product ID equal to 20 or item ID equal to 2. So since it's a or, so any of this one supposed to be true in our execution. So if we run this one, we can see that here item ID is 1 but product ID is already 20. That's the reason it is true and providing this rows. Similarly here item ID is 2 and product ID is 8. Even though product ID is not 20 but item ID is 2, that's the reason it is giving that particular row. Similarly all other rows are provided over here. Okay, then we will move to not condition. That is select star from this table where not product ID equal to 20. Not product ID equal to 20, it is similar to not equal to 20. Okay, if we run this one, you can see it is providing all the rows which are not having product ID 20. Okay, then we are going to in operator. So if we wanted to select records from particular list, so here we can say that there are product IDs like 5, 10, 15, 20, 25, 30. We just want order items having product ID from this list. Then we can write query using in operator Let's run this one, and we can see that product ID is only 20, 10, 20, 15, 5. So all the product IDs are from this list. Okay. Now where clause with between. So if we want to get the result from particular start and end value, that is 5 and 10, then we can go with this between. So when we wanted to use between, always we would require to use AND operator to providing start value and end value. Okay, so here product ID between 5 and 10. So product ID could be 5, 6, 7, 8, 9 and 10. If we run this one, we can see it is giving 8, 10, 9, 7, 5. Okay, and accordingly 585 rows it have written. Now next where clause operator is like. Let's discuss on where clause with like operator. So before discussing this like operator, we have to understand all these concepts over here. So if we are sure that value is ending with 0 but whose initials we don't know, okay, that it could be one character, two character, n number of characters are there, but we are only sure about end values, then we can go with this percentage 0. Let's take example. We know the person's name is ending with Nath, okay, and whose initial we don't know. Okay, so we can use percent Nath. So we could get results like Navnath, Somnath, Amarnath, any kind of results since we have used percent. Okay, so here we can say that percent can raise n number of characters before this hard coded value. If we wanted to ensure that only two characters it's supposed to consider, those two characters could be anything, then we can use underscore 2 times. Since we want two characters, so we will use 2 underscore. If only one character, then there should be only 1 underscore. If we use 2 underscores, then valid value would be like Omnath. Okay, Amarnath would not valid because in Amar we are getting 3 characters, right? These are the 3 characters, whereas here only 2 characters are there. Okay? Similarly, we can apply this at the end in our string. Okay, so if we run this one, we can see that all the product IDs are coming whose last digit is 0. Okay, and if we go, we can see 100 is printed over here because whose last digit is 0. But if we execute this query, it is expecting only one character after this 0. Okay, so this record is not valid for the second query. Let's run this one. Before executing this query, let's look at the number of rows. There are around 424 rows are printed by this first query. Now if we run this second query, we can see there are only 322 rows printed, and you will see that product ID is only 2 digits in this particular result set because we have provided only 1 underscore. If we provide 2 underscore, then it will provide all the product IDs whose are ending with 0 and having 3 characters, because 2 underscore and the last one, and that's the reason it is printing this way. Okay, similarly in third query we are looking for first character should be 1 and then there should be 2 characters in product ID. So if we run this one, you can see first character is 1 in all the product IDs, and then there would be 06, 03, so this type of numbers are there. Okay, there is no 10 because for 10 there is only required 1 underscore. Here we have provided 2 underscore, and that's the reason 10 product ID is not valid. Now here you will see 10 percentage. So percentage means any value, it could be none, so 10 is also valid in this case. If we run this one, we can see 10 is printed. Okay, and after 10 it is printing 106, 3, all those other records which are validating this. Okay, so we discuss where clause with like operator, where we understood the use of percentage as well as underscore character while defining this like condition. Okay, now let's move to any or some. As discussed earlier, any or some both are same, and that's the reason we are just going with any. We don't want to use some. Okay, here in this query we are using any, so we can see that we are using any with subquery. Okay, this is a subquery. Select distinct customer ID from orders table. Okay, if I run this query, you can see customer IDs are printed. Now all the customer IDs printed and any condition is there, so customer ID equal to any of this one. So that's the reason if we run this one, we will get all the records which are matching with this particular condition. Okay, now if we execute same query with in condition like customer ID in, and we are providing this subquery, if we run, we are getting same result. Okay, so we can say that both the SQL queries are giving same results. Then what is the difference? As we discussed earlier, we can use these operators with any, like here we have used, but we cannot use those with in. Correct? So like customer ID greater than any of this one, but we can't use greater than with in. In is always checking with matching value. Then where clause with all operators. So if we see here, we are executing this particular subquery. Okay, and it is giving average product price group by order ID. Okay, and in our parent or outer query, we are checking the product ID should be greater than or equal to all the average prices. Okay, so if we run this one, we can see there are 3 records which are having product price greater than all the average prices provided by this subquery. Okay, then where clause with exist operator. So here we can see that select null means we are getting something. Okay, if we run this one, you can see we are getting null value. Okay, that means we are getting something from this execution, and that's the reason what will happen. Before that, let's run this particular part. Select star from order items. You can see there are around 4722 rows. Okay, and if we execute complete query, we can see all the rows are printed, because this condition is always valid and we are getting something. We can also use not exist. Okay, and if we run this one, we can see we are getting 0 records. Now look at the correlated subquery with this exit condition. Okay, so here we can see that this subquery having where clause with product id from this table equal to product id from outer table, and discount equal to 0.05. Okay, so we have outer table products, we have provided alias as p, and inner table with sales price dot order items, and for this we have provided alias as oc. And to apply filter, we are using where clause by using those alias dot product ids and discount. Okay, and if we run this one, we are getting 268 records, where it is always checking product IDs from product item table as well as products table. If it is matching, then it is checking discount from order item table and ensuring that the discount should be 0.05, and then only it is printing the records from product table. Okay, let me repeat again. So here in where clause, it is checking product ID from order item table as well as product table. If the product ID is matching, then it is checking discount from order item table. Okay, and if that discount is equal to 0.05 for that particular product, then only it is returning that particular product's record. Okay, now let's move to next part. With in condition also we are getting similar result. Here we are just selecting product ID from order item table having discount equal to 0.05. Okay, and all those products are listed in this parenthesis. Okay, and then outer query is executed with products table and having condition like product ID in this list. Okay, and we are getting same result. So either you can use this correlated subquery or this normal SQL query with in operator to get required result. Now what is the difference in between this exit versus in? Both are showing same execution plan. So I can show you same execution plan is there or not. Okay, if we run with in, you can see we are getting same execution steps with same cost. Okay, so we can say with exist as well as with in, we are getting same execution plan. Exist is generally faster than in, as we discussed earlier, because exist is just checking boolean value, whereas in is checking all the values inside this particular list and matching with each of them. Okay, that's the reason in is a little bit slower than exist. Then similarly, exist versus join. In case of exist, we are getting boolean value. In case of join, complete table itself, and then applying required conditions. Anyway, the join part we will discuss in detail when we go to join related SQL queries. Over there, you will better understand about this semi joins or other different joins which are provided by join clause itself. Okay, that's it for this particular video. Thanks for watching.
So enjoying this video? Subscribe to our channel for more exciting content like this. Don't forget to hit the bell icon to get notified whenever we post a new video. Thanks for watching.